Okay, let's dive into this. Welcome to today's Explainer, where we're actually going to do something a little different and honestly, highly practical. We are decoding a real, certified certificate of analysis for a premium batch of EDTA mixed chelating fertilizer. You know, we hear a ton of claims in the agricultural sector about premium ingredients and high performance. But today, we're stripping all that marketing away. We're going straight to the raw data to see exactly what a quality analysis really looks like.
Which brings us to the core question for this explainer. What exactly goes into a premium EDTA mixed chelating fertilizer? And hey, if you're wondering about the word chelating, just think of it as a microscopic protective claw. It holds onto nutrients so they don't just wash away in the soil. To really answer this, we aren't going to rely on assumptions or guesswork. Instead, we're putting our auditor hats on. We're looking directly at the laboratory test results from an actual batch to see how the chemical reality stacks up against the manufacturer's promises. So let's get started.
Section 1. The product profile and the macroscopic details.
Looking at the documentation, the very first thing that stands out is the sheer scale and the precision of this operation. We are looking at batch number 2025-0309. Now, this isn't just some small bench test sample. We are talking about a massive 5,000 kilogram production run. But what's really fascinating is the packing detail. 5,000 individual 1 kilogram bags. That is enough to cover a huge commercial farming operation. It's practically a small mountain of plant food. And pulling that off requires a tremendous amount of consistency to ensure that bag number 1 has the exact same quality as bag number 5,000. And that consistency? It's designed to last. The certificate of analysis highlights a guaranteed shelf life of 2 years, starting right from its manufacturing date of March 9, 2025. So the absolute crucial takeaway here is that this establishes a strict baseline of chemical stability. For the next 24 months, the nutrients packed into these bags need to remain perfectly stable and totally viable for application.
Section 2. 2 physical forms and visual verification.
Now, you'll often see EDTA mixed fertilizers presented in a couple of different ways, which are beautifully contrasted right here. On one side, you've got these grayish-green granules, but on the other side, you see this incredibly vibrant, pure green powder. The laboratory report for batch 2025-0309 specifically tests for and verifies the appearance as pure green powder. This is great because it tells us right out of the gate that the manufacturing process hit its intended physical target well before we even start measuring the chemical compounds inside.
Section 3. The micronutrient breakdown, moving into the microscopic chemistry. Now, what's really interesting about this slide is how zinc and iron completely dominate this chelated mixture by weight. If we look at the hierarchy, we have zinc coming in at 5.1%, followed closely by iron at 4.2%. Then we see manganese and boron tied perfectly at 2.1% each, rounded out with a smaller but absolutely vital touch of copper at 0.5%. This breakdown gives us a perfect, crystal-clear snapshot of the exact nutritional payload this fertilizer is designed to deliver directly to the soil.
Section 4. Specifications versus reality, diving into the laboratory results.
Okay, this data right here, this is the absolute heart of the certificate of analysis. We're looking at the items being tested, the internal specifications required, and then the actual test results. Notice how incredibly comprehensive this is. We already confirmed the appearance matches, but look at the chelated elements themselves. Copper requires 0.5%, and the test result is exactly 0.5%. Molybdenum requires 0.2%, and boom, it hits 0.2% on the dot. As an objective auditor looking at this data, the takeaway is undeniably clear. Every single element tested either perfectly meets or slightly exceeds the required internal standard.
And this brilliantly illustrates exactly what I mean by exceeding standards. Let's just zoom in on zinc for a second. The manufacturer's specification demands a minimum of 5.0% chelated zinc, but the actual lab test result? 5.1%. Now, I know that might seem like a tiny fraction, but in the world of chemical manufacturing, this slight over-delivery is a massive indicator of tight quality control. They aren't just scraping by at 4.9% and rounding up, they are purposefully ensuring the customer gets slightly more active nutrient than they were promised.
And we see this exact same trend continuing with iron. The spec requires 4.0% chelated iron. The test result comes back at 4.2%. Again, we are seeing a really cool micro-narrative forming right here in the data. This is clearly a manufacturer that reliably exceeds its baseline claims. When you compound that extra 0.2% over a 5,000 kilogram batch, well, that is a significant amount of bonus micronutrient being delivered to the end user.
But beyond just the presence of all these great nutrients, the fertilizer actually has to be usable in the real world. That brings us to this highly specific number, 7.7. This is the test result for the pH level when the powder is mixed into a 1% solution. Why does that matter? Well, the specification window for a stable functional product is anywhere from 3.0 to 10.0. A result of 7.7 sits beautifully, right comfortably inside that window. It proves that when a farmer actually dissolves this pure green powder in water, it's going to maintain an incredibly stable pH. That ensures those precious chelated nutrients don't lock up and actually remain fully available for the plants to absorb.
Section 5. The final verdict, quality confirmed.
And here it is in writing, straight from the official report. Quality of this product conforms to requirements of in-house specifications. It's a simple, pretty dry sentence, I know, but man, it carries a whole lot of weight. It officially verifies that the actual chemical makeup of batch 2025-0309 successfully matches, and as we saw, in many cases, actually exceeds its target design. It's truly a textbook example of rigorous quality control verified by crystal clear data.
Which really leaves us with this final thought. We've gone through the raw data together, and we've seen those slight, intentional over-deliveries in elements like zinc and iron. So ask yourself, when a fertilizer consistently over-delivers on its micronutrient specs like this, how does that compound over seasons of crop yield? How much does that precise chemical stability translate into tangible, real-world agricultural success? It's such a fascinating connection between microscopic lab results and massive real-world impact. Thanks for joining me on this explainer, and keep asking the right questions.